Okay, so now let's talk about a very familiar unit that we did last year about power and efficiency. So when we talk about things that do work or machines that do work in our home, we don't often talk about how many joules that machine is consuming. We often talk about how many watts that machine is consuming. So we have a 100-watt light bulb or a 2 kilowatt refrigerator, things like that. So we measure the power that machines are using or producing or consuming. Okay, so what is power? Well, power really is just the rate at which work is performed. So, for example, this runner, if we're going to try to measure the maximum work that this runner can, we're going to stand on top of the bleachers at school and we're going to watch one of your students run up the stairs and we're going to time him. Okay, and then I'd be able to measure how much work that student did against gravity through MGH, so he changed his gravitational potential energy, and we divide that over the time to figure out the maximum power that that student had. Okay, and that power, which is the rate of change in work, measured in joules per second, is measured in watts. So 1 watt is 1 joule of energy per second, or the work required to lift an apple 1 meter off the ground in 1 second. That's 1 watt. All right, so you can try doing that at home. Run up your stairs as fast as you can and calculate the power that you just did to run up those stairs. That'll tell you how many joules of energy you just burned in a second to get up there. Okay, we did that last year as some activities. All right, so that's pretty simple. So to calculate the power of anything, as long as I know how much work it did, either work against gravity or if I pushed an object across a surface. So if I have an object like this and I have a friction coefficient, okay, and here I am pushing that object with a force, okay, the force I will have to apply is equal to the force of friction, and I pushed it, let's say 10 meters in 2 seconds. Wow, that'd be amazing. So if I push that box 10 meters in 2 seconds, well, the power that I would be performing would be the force of friction that I'm applying times 10 meters divided by 2 seconds would give me my power. Okay? All right, so I'd be able to calculate the power of any type of work. Okay, if that's work against friction or work against gravity. What other types of work do we have? Or kinetic energy. Okay, so if I changed my kinetic energy, I can measure my change in my kinetic energy over time, and that would give me my power. So what does that mean? So if, let's say I'm a car, okay, and I don't have to do any work against friction. Let's say I have a kinetic energy of 1,000 joules, and I raise my kinetic energy to 10,000 joules of kinetic energy by applying my accelerator. Okay, and I did that in a time of 5 seconds. Well, then my power is equal to my change in kinetic energy over time, which is going to be equal to 10,000 joules minus 1,000 joules divided by 5 seconds. That would give me my watts of power that I had to use, that my engine had to produce in order to do that. Okay, so if, for example, I know that I used 2,000 watts, let's say more than 2,000 watts. Let's say I used 20,000 watts to complete an activity. In 20 seconds. How much energy did I consume? Okay, so if I used 20,000 watts to complete an activity in 20 seconds, how much energy did I consume? How would I be able to calculate that? Okay, so I just have to remember what a watt is. Watt is joules per second, right? So to find the energy, I can multiply the power times time. That's an important formula for you to know. So if I want to calculate the energy that a machine is using, if I know the watts that it has, and I know the time that it's operating, I can calculate that energy by multiplying the power times time. And why is that? Because energy is equal to joules per second. That's what a watt is, okay? Times seconds. The seconds will cancel out, and I'll be left with joules. Okay, so that proves that power times time gives me my change in energy. Okay, that's the beginning of what I wanted to teach you guys with power, is understanding what the unit of watts is, how to calculate power and different types of power. It could be any different change in energy that we're looking at, divided by time. So it's the rate of change of that energy that would give you the watts. And what we can do with the watts is calculate the total energy used by a system if I was given the watts, okay? But let's talk about a very specific situation, okay? Let's say a car is traveling, so that you're on the highway, okay? And the car is traveling at, let's say, 40 meters per second at a constant velocity. Okay, so one thing I remember from Newton's law, if I'm traveling at a constant velocity, my car doesn't have to apply any force, right? Because I'm not accelerating. So that's kind of weird. So that would mean that if I'm on the highway and I apply my accelerator and I get to 40 meters per second, I can just let go of the gas pedal and my car will stay at 40 meters per second. But that's not true, because as soon as I let go of my accelerator, what's going to happen? The car is going to start to slow down and then come to a stop, okay? Because there is force of friction. There's resistance. They got friction on the road. You have air resistance. So despite the fact that I'm traveling at a constant velocity, my car is definitely applying a force. And in order to apply that force, my car is consuming energy. It's burning fuel, okay? So it is consuming energy over time, and my engine is using power to maintain that constant velocity, okay? And I'm going to show you another formula that we can use, okay, to calculate power. So power can also be calculated of an engine by looking at what is the force that it's applying times the velocity, okay? So if it's maintaining a constant velocity, and I know the force that it's applying, if I multiply those two things together, that will also tell me watts, okay? Now, how does that work? Well, force times, now what is velocity? Velocity is distance over time. It's my change in distance over the change in time, okay? Well, force times my change in distance over time is equal to work over time, okay? And work is the energy, time is the amount of time that I'm doing that for, and that will give me my watts. Okay, so here's that interesting formula where if I know the force that I'm applying and I know my velocity, I'll be able to calculate the power. So how would I be able to calculate the force? Well, in a problem, they could give you the friction coefficient, you know, the force of gravity on the car, because let's say it's 1,000 kilograms. And if it was just friction, you could calculate the force of friction that the car is applying, is working against, and that would become the force of friction times your velocity. Okay. On the other hand, you could have air resistance, and if they told you what the force of air resistance would be, you would add that to the force of friction, put that together and multiply by your velocity and get the power. And other interesting problems are, and this could be somebody's IA, is you can actually calculate, you'd be able to calculate air resistance, the force of air resistance, if you're able to somehow measure the power that you're applying in a machine to get it to travel at a constant velocity, okay? And then you would be able to work backwards. If I was able to measure the power that I'm applying, let's say I have an engine that applies 60 watts for a remote control engine, okay, and I put it full blast and the car will get to a constant speed. Well, at that constant speed, I'd measure the speed, I know the power, I'd be able to actually calculate what the force of friction is, okay, from that situation. So power divided by that speed at which it's going, the constant speed that it attains, is going to give me my force. So that's an interesting relationship that I can play around with. Okay, so here is just a brief explanation. I want you to go back to the electronic Chocos textbook that I gave you guys, and I want you to look at some of these problems where they actually have a car that is driving and it lets go of the accelerator, and then you're able to measure the force of friction from a kinematic situation, okay, and then be able to calculate the power of an engine. Those are excellent problems to look at.